Hello again. In this part, I'm going to be talking about virtualization. And a long story short about virtualization is that when you have certain computer that has certain operating system and you want to run a different operating system on that one. So why would you do that? Well, because you want to run certain program. As an example, at the AUM, we have Verilog as an example, and the system that you guys are using to run Verilog doesn't really get installed on Mac as an example. Okay, those who have Mac, they would know this agony. Okay, so here is the Mac, and you want to install whatever Verilog package. Okay, but Verilog runs on Windows, so you install here a virtual machine so you can run the Verilog into a Mac. Okay, so this is a long story short. So what does virtualization do? It allows the operating systems to run applications within other operating systems. That's exactly what I was talking about. You run Verilog on Mac, even though there's no version that has been done yet of many packages that run Verilog on Mac. Okay, at least not that I'm aware of. Of course, it's a vast and growing industry, the virtualization, for many, many reasons, especially after the cloud computing became very popular. What it does mainly is emulation. Okay, emulation. So what does emulation mean? Okay, it means that it imitates different architecture. Okay, so used when source CPU type is different from the target type. What does it mean? You have a RISC computer and you want to run CISC for whatever reason. Okay, how would you do that? You emulate, you map the code so that it actually runs on CISC, emulated CISC, but it gets mapped to RISC architecture. Okay, like as an example here, PowerPC to Intel x86. All right. Of course, generally the slowest method, that's very logic, because you literally map different computer architectures. And when computer languages, they're not compiled to native code, why would that happen? Because of the different architecture. When you write C code and you get it compiled on Windows, and then you move the executable file that you created in Windows to Mac, it doesn't run. Okay, so you have one of two solutions. Okay, the first solution for this particular scenario is to recompile again on the Mac. Okay, so you GCC your code on Mac. Okay, so you need the source file, and then the source file, you get it compiled. If you don't have the source file for whatever reason, then you need to interpret your code. How would you interpret it? By also the virtual machine that will interpret that one. So when computer language not compiled to native code, you get interpretation. The visualization here, okay, the operating system natively compiled for CPU, certain CPU, not just CPU, of course. I mean, for whole architecture. Okay. Now you have running guest operating system. So if you have Mac and then you put a VM for Windows, which is a crime. I don't know why would anyone install VM on Mac, even if the package that you're looking for is not available for Mac. You should be trying to find an alternative rather than installing VM of Windows, which is not really the best system on an amazing operating system like Mac. So that would be the case. So in this case here, we call this the guest operating system. And of course, this is the host operating system. Okay. This is done using what we call VMM. What is VMM? V for virtual, M for machine, and M for manager. Here it is. Okay. So virtual machine manager. Okay. It provides the virtualization services. Okay. What are those services? Many services, including the interpretation that we talked about, the emulation in general, and so on. Okay. So, long story short, you have here, let's say, hardware 1. You can have a VMM to run certain software that is actually compiled for hardware 2. Okay. You can also have here the hardware, but you have some operating system. I'll call it operating system 1, and you want to run stuff for software for operating system 2. So you get also a VMM that does that. I hope those two illustrations are made it very clear. The use cases, as I mentioned, Apple laptop running Mac OS, that's the host, the original one, and Windows as a guest. A crime. Don't do that. Developing apps for multiple operating systems. So now if you have a company and you want to save money, what you can do is you have here computer. Okay, and then this computer has its own original operating system. And then you have different VMs for different operating systems. Why is this? So let's say you wrote a program that runs on the original operating system. Here it is. You wrote another program, okay, or you want to recompile the same program with for a different operating system. Here it is. Here it is, and here it is. So what did you do here? You saved money for, 4 different computers with 4 different operating systems. Of course, this is gonna be very, very slow because of the so many virtual machines that are there as I drew the illustration here. All right. Also for the quality assurance, the QA, right? For any software company, they have a department called, like big ones, QA. Okay. If it's not a big one, they hire just one that does the QA, which is not really, recommended. You need a team for the QA for the validity and the correctness of the software. So the same idea here, right? So you can have here your computer, that have an operating system, but you want to test the software that is written for different operating systems. So instead of buying different computers for different operating systems, you can literally put VMs. Okay. Now, when we're doing the mobile applications, you literally have a VM that mimics the operating system that you're using, or that you're gonna be using, or you're gonna install your application on. Okay, so as an example, Android Studio, if any one of you used it, it has an emulator for the Android. So what you see is what you get, literally. Whatever happens on this emulator, it will happen exactly the same when you install the app on the device. Okay, so this virtual machine that is embedded inside the Android Studio mimics the hardware and the operating system of the Android phones. Okay. So here, executing and managing computer environments within data centers. I'll leave this, I'll talk about it later when we talk about the cloud computing. So virtual machine manager can run natively, so compiled on the original operating system and hardware, in which case they are also the host, because they're native. Native means they are compiled on the same machine and on the same operating system. Now, there is no general purpose host, then, you use VMware. By the way, VMware is a huge company that is famous for virtual machines, is VMware, but they also acquired and bought some big companies. One of them is called Pivotal Labs. It was the company number one for app development, and they actually did the Facebook app on the phone for Facebook. They did the Twitter, they did Instagram, all those apps, the Pivotal Labs did it for them. Pivotal Labs. I know it's not really related, it's just, because we mentioned VMware, Pivotal Labs need to be mentioned. It's a huge company that made all, big applications that you use. Okay, now, here is a model, see? This is without a virtual machine. So you have here the processes. They talk to the kernel, as we talked about it before. Here is the kernel, so they deal with the kernel, and the kernel controls the hardware. Okay, so kernel is the programming interface, this one, all right? Or in other words, this line is the programming interface that literally deals with the kernel. Now, look at this. You have different processes for different operating systems. Okay, so you have here a few processes for kernel 1, okay, that deals with VM1. You have a set of processes for kernel 2 that deals with VM2, and processes for VM3. Okay, they're all built on the virtual machine manager, the VMM, okay, that deals with the hardware. Okay.